So let's read the question. AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. Show that AD bisects BC and AD bisects angle A. So the first step is draw your figure. So let's first draw a figure. So what do we have? We have an isosceles triangle ABC in which AB is equal to AC. So let me first draw an isosceles triangle ABC. So let's say this over here is our isosceles triangle ABC. Now what is given to us? AB is equal to AC. So immediately mark AB is equal to AC, right? Next, what is given to us? AD is an altitude. What is an altitude? AD, that means a perpendicular from A to the opposite side. What is the side opposite to A? BC. So drop a perpendicular from A to the opposite side BC. It is an altitude. So this will be 90 and this will also be 90. So remember, altitude means height. It is always perpendicular, right? So this over here is our figure AD, right? So the first step is always draw your figure. What is given to us? AB is equal to AC and these two angles are 90. Now based on this, what do we have to prove? We have to prove that AD bisects BC. So we have to prove AD bisects BC. Bisect means to cut into two equal parts. So we have to show that AD is dividing BC into equal parts. Which two equal parts? BD and CD. So what this basically means is that AD bisects BC. That means we have to prove BD is equal to CD. I hope this is clear. See, we have to prove that AD is dividing BC in two equal parts. In which two parts is it dividing? BD and CD. So we have to show these two parts are equal, right? Next, AD bisects angle A. AD bisects angle A. Bisecting an angle means dividing the entire angle in two equal parts. So we have to show these two angles to be equal. So what do we have to show in this question? We have to show BD is equal to CD and these two angles to be equal, right? So hopefully you've understood that. Now how do we show it? See, whenever you want to show two sides to be equal or two angles to be equal, what do we do? Choose two triangles, which have these parts, show them to be congruent. By CPCT, we'll get this. So which are the two triangles? This and this. Triangle ABD and triangle ACD. So let me take these two triangles. So we have in triangle ABD and triangle ACD. Now if you notice, we have two right angle triangles over here. So whenever you have two right angle triangles and you want to determine congruence, use the RHS criteria. Right angle, hypotenuse, side. So first of all, write on the right angle. So we have angle ADB is equal to angle ADC, which is equal to 90 degrees. This over here is given to us. So this over here is the right angle. Next, search for the hypotenuse. Which is the hypotenuse? Side opposite the 90-degree angle. Here it is AB, here it is AC. Are the two hypotenuses the same? Yes, AB is equal to AC given to me. So write it, AB is equal to AC. Why? This over here is given to us again. So this is basically the hypotenuse. So hypotenuse. Now if we can get any one side to be equal, our job is done. So which side is equal? See, AD over here is a common side. I repeat, see, AD over here is a common side. AD is part of this triangle as well as this triangle. So AD is a common side. So I'll say AD is equal to AD. So AD is equal to AD. What is the reason? Common side. So what is this? Side. So basically RHS criteria has been satisfied. This implies the two triangles are congruent. So triangle ABD is congruent to, see, AB corresponds to AC. AB's first two letters. So first two letters over here, ACD. So AB is equal to AC, AD is equal to AD, and angle D is equal to angle D, right? Which is the criteria we've used? RHS. So RHS congruence rule. So remember, the moment you see two right angle triangles, try to use the RHS criteria. So moment you see right angle, just get the hypotenuse and one side to be equal. Hypotenuse one side to be equal, the two triangles are congruent. So now that the two triangles are congruent, it is simple CPCT. So how do we get BD is equal to CD? Get the side corresponding to BD from the congruence statement. How do we do that? First label 1, 2, 3, 1, 2, 3. Now I want the side corresponding to BD. Search for BD in the congruence statement. BD is over here. BD is what? Second and third letter. So second and third letter will correspond to second and third letter. What is second and third letter here? BD. What is second and third letter here? CD. So BD is equal to CD. Similarly, I want to get these two angles to be equal. This is angle A of this triangle. This is angle A of this triangle. So let's see if they're equal or not. Look for angle A. A is first letter. So first letter will correspond to first letter. So A over here, A over here. That means angle A of this triangle is equal to angle A of this triangle. What is angle A of this triangle? This over here. So angle BAD. So first letter corresponds to first letter A. That means angle A of this triangle, this angle CAD. Right? How did I get this? CPCT, corresponding parts of congruent triangles. So we have shown BD is equal to CD and these two angles are equal. Because these two angles are equal, this implies AD bisects angle A, right? And because BD is equal to CD, that means AD bisects BC. So this implies AD, I'll write it with a different color. So this implies AD bisects BC, right? So BD is equal to CD, that means AD bisects BC. These two angles are equal. This implies AD bisects angle A. So I'll write it once again for you in case it is not clear. So BD is equal to CD. This implies AD bisects BC. Similarly, these two angles are equal. Angle BAD is equal to angle CAD. This implies AD bisects angle A. So I've just wrote it over here in a more clean manner. So basically BD is equal to CD implies AD bisects BC and these two angles are equal. That means AD bisects angle A, which is exactly what we had to prove. So hence proved. So this is how you solve the question. So the first step is always draw your figure, understand what is given to you. Next step, what do we have to prove? AD bisects BC. So it is dividing BC in two equal parts. That is BD and CD. So prove BD is equal to CD. Next, AD bisects angle A. It is bisecting the entire angle A. So it is dividing entire angle A in two equal parts. That means these two angles are equal. That is angle BAD is equal to angle CAD. So it's a good tip, just write in bracket what you have to prove. So you know what you have to prove. Now how do we show two sides or two angles to be equal? Simple. Take two triangles which have them of their parts, prove them to be congruent. So I took these two triangles. How do I show them to be congruent? First look at what is given to you. AB is equal to AC, given to me. These two angles 90, given to me. The moment you see two right angle triangles, apply the RHS criteria. R known to me, H known to me. I need one more side, AD is the common side. So by RHS criteria, the two triangles are congruent. So by CPCT, we get BD is equal to CD and these two angles to be equal. So you can write BD is equal to CD. This implies AD bisects BC. These two angles are equal. This implies AD bisects angle A. And very nicely, hence proved, right? So this is how you solve this question. So I repeat, draw your figure, understand what is given to you, understand what you have to prove, right? Whenever you have to show two sides or two angles to be equal, choose two triangles, prove them to be congruent. Begin always with what is given to you. And then whatever is left, try to conclude it. Get your congruence and then by CPCT, get your corresponding angles or sides to be equal, right? So this is how you solve this question.